Hey friends, this is a video lesson for lesson 1.4 in our light waves unit of study. I wanted to start off with a little bit of a bunny trail because I noticed something. Here we are in the very entrance to our school, our foyer. And if we go into here, our little holding tank, there was something so cool, you guys. We just started light waves and we're learning about different wavelengths of light and how those different wavelengths can cause changes in material. Well, one of those wavelengths that we learned about in our last lesson was infrared. And what's really cool about infrared is infrared allows us to see heat or measure heat. And so today I wanted to start off just by showing you some new additions to the school. These are well, I guess you would say thermal scanners, right? And so when I go over and I stick my, let's see if I can.
Temperature, please wear a mask. Normal temperature, please wear a mask. Normal temperature, please wear a mask.
Check that out. So what these devices are doing right now is they're actually using a certain spectrum of light, infrared, to measure my body heat. It said I was 97.7. The other thing it's doing is it's recognizing that I'm not wearing a mask and it's reminding me to do that. So I thought that was pretty cool. So, friends, I just wanted to share that with you. I'm going to pause this and then get back to my desk and we'll start lesson 1.4 together. All right, friends, so we are back. Sorry, I lost my, you can't see my face. It's hiding somewhere. I can't get it back. So today, again, I just want to remind everybody, these videos are intended for you to pause the video throughout the video, complete the activities as I show you in the video. I will be saying, hey, pause the video, do this. So just follow along. So we have lesson 1.4 here, and we're going to dive right into that. So there are 5 parts in Amplify. We are going to skip the last part. So for all of my friends who are close readers and paying attention during the video, awesome. You'll notice there are 2 files here. One's a link, and then one is a Google slide, and that is a modeling tool that we're going to be working on and turning in as part of a graded assignment for today. So let's dive right into Amplify. As usual, we will be logging in with our Tumwater accounts. And Amplify, of course, likes to start us off with a warm-up question. So for this one, let's close this guy down and let's make this bigger. Yeah, there we go. So for lesson 1.2, it says you observed that a solar-powered toy moved when you shined a flashlight on it. Select all of the statements that you think are true. So, friends, this was lesson 1.2. This was the hands-on video where Mr. Roberts went around and shined light on, it was a little solar-powered toy. It was liquid crystal, that paper, and then also the thermometers. But we're talking about the solar-powered toy. What I'd like you to do is pause the video and answer these 2 questions. So go ahead and pause right now. All right, so hopefully you answered the 2 questions. I would like to share out the correct answers though. Because honestly, if you can get these this question right, you're gonna do really well on our first chapter quiz. So this statement, light from the flashlight carried energy. Well, all light carries energy, so I think that statement might be true. There was energy in the toy that was activated by the light. Well, see, if light is the carrier of energy, there was really no energy that was activated within the toy. So that is incorrect. Energy from the flashlight was absorbed by the toy. Absolutely, I agree. I think that statement is true. Energy from the okay. So this other statement, the flashlight absorbed energy from the toy. So you really have to pay attention. We know that light's carrying energy. We're going to select that one. And we know that energy from the flashlight was absorbed by the toy because whenever light is absorbed, that's when we see a change. And we saw a big change when that solar powered toy started gyrating incredibly fast. The flashlight absorbed energy. Did the toy send energy to the flashlight? No. So these are our two correct. Make sure you push that hand in button when it is all said and done. Now we're going to go on to our modeling tool. So for part 2, this is our modeling tool. It wants us to choose a source from the word bank. It wants us to choose a change from the word bank. And then it wants us to use yellow to trace the path of the energy. And if you scroll down here, all there is a word question. So again, what you're going to need to do is go back to Google Classroom, open up your modeling tool, and let's complete this activity. Let's see if I can get this. Control Alt bigger. There we go. Ooh, too big, Roberts. That should work. So what we have here is a model, and what we are trying to do is we are trying to show how light from the sun can cause skin cancer. So it's light from the sun causing skin cancer. And there's some instructions here for us to follow. Select a source and drag it over. So we have two sources. We have a light bulb and we have the sun. Remember, we are trying to show how light from the sun can cause skin cancer. So out of these two sources, which one do you think you should drag over? Yeah, it's probably not light bulbs. So what we'll want to do is take our sun and just move it on over. You know, I'm going to have to make this just a little smaller just so I can more easily move some things. So there's the sun. Okay. Now we have to, let's see, we selected a source and we dragged that over. Pretty confident that since we're trying to show how light from the sun can cause skin cancer, we want to put sun there. Select the change you expect to see. So we've got a change box right here. And if we scroll over, we also see we've got several changes. So let's really look at these. So if light is hitting that from the sun is hitting that genetic material, we'll start at the bottom. If it's being absorbed, we should see a change. So we know that none is a non-example. Okay. Warmth. So when light from the sun hits genetic material in the skin, is that going to create warmth? Absolutely, it will. But we have to kind of slow our roll on this, right? Because again, our mission is to show how light from the sun can cause skin cancer. And warmth does not cause skin cancer, which is why it's okay to put on a jacket. For genetic material, photosynthesis does not occur in genetic material. It occurs in specialized cells within plants. Movement. Let's see. Could we get some movement from the genetic material? Yeah, we totally could. Remember, we already said warmth is an option. Well, warmth is really just movement, which is really just speed, which is really just kinetic energy. So when you go out in the sun and the sun shines down on your skin, there is an increased movement, even down to the atomic level of the atoms and molecules that compose your body will start to move. But that movement is not necessarily causing skin cancer, right? Because again, we already went over how movement, heat, warmth, kinetic energy really does not cause cancer. However, it does cause damage. And if you reflect back to our work that we did in the sim, we saw that when we shined light onto genetic material, one of the results was damage, especially as it absorbed the ultraviolet radiation, X-rays, and gamma rays. All right. Hey, let's get out of here. So we have one more task here, friends, and that is click on the light line and change its color to yellow to show the energy path. So just like down here, we've got this little yellow. We want to click on the light line and we want to show the energy path. And this is great because it shows that the that light travels in a straight line. It shows that the sun is what's carrying the energy in that straight line and causing the damage to our cell. So friends, if yours looks like mine, you are done. Make sure that you turn that in, but we are going to keep on going in our lesson now. So use your model that you just did, right? And here's what you want to do. Answer this question. How can light from the sun cause skin cancer? Let's go ahead and take a moment to pause the video. Make sure that your modeling tool is all up to date and answer this question. So pause the video now, get this done. Woohoo, you did it. At least I'm hoping. So, what are some possible answers for this? Well, I'm going to go to my cheat sheet here and possible responses. Let's look at this model. So here we can see, yeah, even bigger. Here we can see this is what we should have got. We've got our source. We've got our light that's carrying energy. The energy from the light is absorbed by the genetic material, which in turn is causing damage. And our response could look something like this, right? So light from the sun carries energy. When light from the sun hits a person's skin, the energy can be absorbed by the genetic material in the skin cells, and the energy can damage the genetic material. This damage can cause skin cancer. Okay, so hopefully you have something like this answered here. Push the hand in button, and let's move on to the next one, shall we? Okay, this activity is designed for you to be working in pairs or small groups. Obviously, we are not doing that in this distance learning model that we're in. So let's go through the video together, or let's go through these together. And I would like you to copy and paste some answers and then just turn it in, okay? So here's what we're doing for this part. We're investigating claims. So again, this goes back to a model that scientists use called the CER model. And so what we do is whenever we're confronted with a claim, we look for evidence, and then the R is our reasoning. So CER, claim, evidence, reason. So we're going to dive into these three claims, in particular that first claim today. And again, we're trying to answer our chapter question, why is Australia's skin cancer rate so high? Claim number one says Australia gets a lot of sunlight. It does. Claim number two, there is something different about the sunlight in Australia. That's an interesting claim. I'll give you a hint. There is. And then claim number three, more people in Australia have skin that is easily damaged by light from the sun. Now, normally when we do these, I like to let you guys discover the answer, but I'm just going to tell you right now, friends, claim number one is incorrect, and we're going to see that today. Claim number two and claim number three are correct, and we're going to learn a little bit more about those reasons why later. But claim number one, let's dive into some of the evidence. So let's go to the part two here. So you'll see it says student one, and there'll be a student two. Here's student one and student two. So claim number one is that Australia gets a lot of sunlight. But that claim is true, but is that the reason why Australia's skin cancer rate is so high? Let's dive in a little deeper. So if we look at this map, I already put some tags here. Sorry, my bad. I was playing around earlier. You won't see these on yours. If we look at this world map, we can kind of see two areas down here in the southern hemisphere which have a very similar amount of sunlight. So we've got Brazil over here, and it gets somewhere between 2,000 and 3,000 hours of sunlight per year, and Australia gets about 2,000 to 3,000 hours of sunlight a year. Incidentally, up here in the Pacific Northwest, Little Tumwater, we only get, let's see, what color are we? We're that, like the lightest yellow on there. So I think we are here. I think we get somewhere between 1,000 and 500 here in the amazing Pacific Northwest. So if claim one is accurate, what would you expect Brazil's skin cancer rate to be? Would you expect it to be the same as Australia, judging by getting the same amount of light? Would you expect it to be different? Or, I'm sorry, would you expect it to be higher, lower, or the same? So let's look at this map. Here's Brazil. Over here is Australia. If this claim is correct, the reason why Australia's skin cancer rate is so high, what should we expect Brazil's skin cancer rate to be? Let's go ahead and answer that question. Go ahead and pause the video. Answer the question. Okay, so hopefully you chose it should be the same as. So that would mean to test this, all we have to do is look at skin cancer rates in Brazil and Australia and see if they are the same or not. Now, I would like you to do this, answer this question, because you do need to understand the concepts of absorb, energy, and light and how they all relate. So if claim one is accurate, I would expect Brazil to have a cancer rate that is the same as Australia's. Now you're going to answer why. You want to explain your thinking using these three words. Go ahead and pause the video and answer that now. All right, friends, so hopefully you have a response something like this. And it goes a little like this. I would expect Brazil's skin cancer rate to be the same as Australia's skin cancer rate because light from the sun carries energy that is absorbed by the genetic material in skin cells. This can cause damage, which can lead to skin cancer. All right, guys, we are going to go to look down at the bottom here. We've got another part. We're going to go and just explore together. So in this case, we're looking at Egypt, okay? And what we're doing is comparing Egypt's total hours of sunlight. So they get over 3,000 hours of sunlight per year. Australia gets 2,000 to 3,000. So a little bit more, I would say significantly more in Egypt. And so we're going to answer that same question. If claim one is accurate, which is that Australia gets a lot of sunlight, and that's why there's such high skin cancer rates. If claim one is accurate, what do you expect Egypt's skin cancer rate, considering it has a higher amount of sunlight? Go ahead and pause the video. Make your selection now. And hopefully you chose higher than. That would be an example of reasoning where if claim one was correct, Egypt does indeed get more sunlight, we should see an increase in skin cancer rates. So to investigate that, we can go look at skin cancer rates here in a little bit. Now, for this part, because it's a lot of the same and repetitive, you can just copy and paste your answer from before. I know it won't necessarily be the exact same. We can change maybe Brazil to Egypt, right? Boom, nailed it. Push and then hit save and continue. Let's go to the next one. So same thing, but now we're going to look at Japan. So Japan is right over here. You see it's got that kind of mustard yellow color. So that gets anywhere from 1,000 to 2,000 hours of sunlight per year compared to Australia's 2 to 3,000, right? So if Japan has less of a of sun exposure, then what do you expect its skin cancer rate if claim 1 is accurate? Go ahead and pause the video, make your selection. And hopefully you chose lower than for this part, because yes, it would be lower if claim 1 is correct. We are going to skip answering this part right here. We're going to go to part 5. Okay, so this is where we're really going to dive into these two claims. Control plus. So again, we compared Australia with Japan. I want this guy. We compared Australia with Japan, and we can see they have much more sun down here in Australia. We compared Egypt with Australia, and Egypt had much more sun than Australia. And we also looked at Brazil, and Brazil has about the same. Now, if we compare that over here to our actual map of skin cancer rates from around the world, again, we see Australia has a super high rate, higher than anywhere else. We see Japan has a lower rate, right, than Australia, which means if we were just looking at Japan and trying to figure out if claim 1 was if that claim that Australia just gets a lot of sunlight and that's why there's skin cancer, then we should see places like Egypt be higher and Japan be lower. But we're seeing Japan is lower, so that kind of matches up. But then look over here at Egypt. Egypt's just the same as Japan as far as skin cancer rates are concerned. And yet, remember, they had over 3,000 hours of daylight per year. So that really damages claim 1 and refutes it, I would say. And then the icing on the cake was our first one, looking at Brazil. They have a significantly lower amount of skin cancer than Australia, yet they receive the same amount of sunlight per year. Now, if we go back to our initial claims right here to part 1, I think we have gone ahead and refuted claim 1. In other words, we proved it to not be true. We are going to dive in deeper as we go. For claim 2, there is something different about the sunlight in Australia. There is. It's called the ozone layer, and it's really thin, and there's a big hole over Australia, which lets in a lot more ultraviolet radiation and actually other spectrums of light as well. The other thing is we kind of already discussed, and that is more people in Australia have skin that is easily damaged by light from the sun. Remember, Australia was colonized by Europeans, Western Europeans, and just genetically, they don't have the protections to be able to generate enough melanin in order to provide protection from the sun. So part 3 is done, friends. Make sure when you get all the way to part 5, you push that hand in button. And now we're going to do our final part of the day. And it really is kind of a little bit of a repeat of what we just did. But you are going to answer these 3 questions. So what does the world sunlight map tell you about how much sunlight Australia gets compared to Brazil? So I'm not going to hold your hand for this part. I trust that you guys can answer that question on your own. So we're looking up here. We're comparing Brazil, which is in South America, to Australia, and we're answering this question. What does the world sunlight map tell you about how much sunlight Australia gets compared to Brazil? Then answer this question. What does the world skin map tell you about how the skin cancer rates of Australia and Brazil differ? So you're going to do that same comparison. You're going to look at Brazil, and you can see their skin cancer rates are looks like 10 to 40 incidences per 100,000 versus Australia, which is greater than 220,000. So look at these two maps, look at the data table, and then answer this question. From looking at that map, what does it tell you about skin cancer rates in Australia versus Brazil? Last question, what ideas do you have about the two places that could have the same amount of sunlight but different skin cancer rates? I will let you answer that question independently. I'll give you a hint. Claims 3 and 4 that we just went through earlier in the lesson will be the way to go. All right, friends, make sure you push the hand in button. Make sure you go back to Google Classroom. And for this assignment, you do need to turn it in because you are doing a graded assignment right here for this modeling tool. All right, friends, thank you for watching. Don't forget to like, comment, subscribe, share with your friends. Be nice, be awesome, and I will see you next time.